How's everybody doing this afternoon? I'm glad everybody came back because nothing kills a mood like math. Right? So we had a packed house earlier today. We're going to jump into it here. We're going to be talking about this afternoon data science and cyber. We're not going to get too deep into algorithms and all the other crazy stuff. We're the mathematicians in the house. One? Okay, good. I think we can all take her. Two, we can, yeah, we'll be fine. So we'll jump right into it. Some of the things we're going to talk about is going to be data science and more, right? Talking about data, and you're going to hear me say it's going to be like that insurance commercial again where they go free, 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 free. You're going to hear me see data, 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 constantly throughout the brief because it's really what we're talking about, right? Data science, data analytics, data products, those different types of things. So we'll briefly touch on what data science is. Everybody familiar with data science? In depth? Really understand it? Right? We'll talk over it. We'll talk about some cyber influences on data science, the good, the packet, and the statistics. Right? Some of the things that we do, some of the things that we need to rethink about in the cyber world when we're talking about data science and about network defense and about network attack type things, right? Data science and cyber operations and the way of the data science where we'll talk about the things that we need to do as a community across the board to kind of facilitate an upskilling of analysts and network defenders and whoever might be participating in this realm, for managers all the way down to the worker bees, on what data science is and some of the skill sets and some of the tools that they might be using. And hopefully, if you're in a managerial position or a C-suite or leadership position, you'll be able to take some of these back and start asking your folks, like, hey, are we doing this? Are we preparing? Are we positioning ourselves correctly for these other pieces and stuff, right? And I swear we're going to go 60 minutes as long as you guys participate and ask questions. Some of the stuff will be audience participation, so ask questions, talk about things, share stuff as we go along. A little bit about me before we continue on, right? So I'm a retired CTN chief, was retired in 2010. My career started as tactical communications, and then I switched over about 1998 to network security, network administration, those types of things. I was on NSA's red team and blue team for a few years. I was also on the national NSA's Threat Operations Center. I joined Intelligenesis in 2010 and have been doing data science-like mentoring for 9+ years or so now. I recently switched over. Aside from the other contracts I work with my company, one of the things I just started doing in the past 6 months is I'm the sole contractor with the curriculum manager, and we're rebaselining all the data science curriculum for the National Cryptological School. So we're trying to gather all that stuff in and trying to figure out a way to train analysts within the National Cryptologic System and the IC to pick up data science skills and data science knowledge, and also looking forward into the future on how we're going to maintain those skills for our data scientists. Right now, there's no data science training within the IC for data scientists coming in, and we're competing against an industry that is routinely siphoning them off, right, as fast as we can get them in. So we're building those pieces out. And again, we're going to go the full 60 minutes. We'll have time for questions, but I'll hang out afterwards to talk with anybody if you have any questions or anything else. All right. So what is data science? Right, a top-level overview thing is a process of defining new hypothesis, right? Identifying a problem, whether it's your business need or whether it's your intelligence need or it's your cyber attack planning, whatever it could be, right? Something that you need to do with data to answer your question, right? How many people have routinely asked questions about planning and needed data? Everybody in the room, right? Everybody needs data. Everybody's looked at data, all those other things, right? Part of it is also acquiring the data, understanding where we get data from and how the data is feeding into our repositories, right? Whether we're feeding into a AWS storage area, or we have a standalone server someplace where we have SQL running, or a Cumulo, or whatever it might be, where we're storing data, and how to get that data into there. Preparing the data and analyzing the data. Right, so understanding how to groom it and prepare it for analysis and for data science. And we're going to talk a little bit about more as we go on, So creating new algorithms and new models to, once we've done some initial analysis, to go in and do the heavy lifting of that stuff. And then also visually outputting that information, right? Everybody that's ever done any work with data loves rows and rows and rows of data in a database, right? Anybody love looking at those rows in Excel and CSV files? And that's the most exciting part of a data analyst day, right? It's really great if you're an uber nerd. It's not so great if you're management or if you're the consumer who is asking a question. Just tell me what my data is telling you so we can go on and make a determination and move forward from it, right? So understanding the data and producing some visualization from it. And we'll talk a little bit about those as we continue going on. So who are data scientists, right? Personnel-wise, we think of it mainly as, and I won't say that there's a huge divide, but there is somewhat a divide in trying to define data science, right? Within the IC community, within some of the other organization stuff, we're still trying to capture what we want a data scientist to be. Mathematicians are the first ones that roger up with it, right? Because it's mainly, or has been in the past, been really heavily influenced by math, right? Because of statistics, right? And the need for linear algebra and these other high-level mathematical equations to apply these models or build these models around and feed into to gain that intelligence out of. But it's also computer scientists. Right? It's a data analyst, right? Whether that's going to be a cyber threat analyst, a business analyst, right, or all the way down to even sports analysts. Anybody seen the movie Moneyball? Moneyball was based on a guy who was doing data science on baseball players, right, to find the best players they possibly could at commodity prices, right? So that's a real world example of data scientist. Now, did they call him a data scientist? No, he's just data guy, right? Pulling this piece up. But what he did, some of the pieces he was putting together and everything else, underlying was establishing some sort of data science process to find the information and use what was available to bubble up those players and stuff, right? Urban development analysts, right? So people who are planning out cities and doing all kinds of other pieces, right? They pulling data from all other places. And I just realized it says Urbana because my son goes to Urbana High School. And it probably auto-corrected to Urbana. Sorry about that. I'll get to get it corrected. Right. So some of the skills that we need these people to do or to have, and we'll get a little bit more in depth a little bit later, but the main thing is going to be scripting, right? We think of data analysts or data analytics. We take a CSV or JSON file or something and put it into a spreadsheet like Excel or Google Docs or whatever it might be. Create a pivot table or do something else with it, right? But it's much deeper than that. We need to be able to pull data in from multiple different sources and know how to manage that data through either Python or through R, or even when we start talking about machine learning and adding large data analytics, right? Looking at Scala or PySpark or some of the other languages out there that are a little bit more high level and get us down into the weeds. Understanding statistics, right? So we have to be able to, as analysts, and as cyber warriors, wherever we're at, is have some sort of basic understanding of what statistics are. A little bit more than the mean and mode and standard deviations between 2 points and all those other things. Those are great. You can put it on a chart and show that it's fluctuating and everything else. But how do we use those statistics later on to prove or disprove or support our findings within the data output and the data production, so that we can go to somebody and we say, hey, here's the output of your data, and this is what it's telling you. What's the second question they're going to ask? Like, prove it, right? Tell me what are the numbers behind it. Show me that you're not just making some pretty picture on a map someplace or some graph and outputting it from there, right? The math portion of it, right? Aside from statistics, right? Calculus and linear algebra. Those are things that we don't typically in the computer science world think about as needing. But on the mathematics side, it's the core foundation of it, right? We could talk about calculus and linear algebra and trigonometry and all these other pieces and how they all fit into a higher level math. And one of the things that we need to, as a community, one of the contentious parts about data science, and two factions I work with right now are the mathematicians, and then the advanced data analysts, right? The advanced data analysts want this, or have this idea of citizen data scientists, right? And the mathematicians are like, there's no way that anybody could do data science if you don't have a math background, right? Possibly the higher level math stuff, yes. But one of the things I like to point out to them is we have things like self-help stores like Home Depot and Lowe's and Ace Hardware. You know, everybody that goes there is not a builder per se, not going to build the house, but they can go and they can fix something. They can get to a certain point. Where we need the community is to realize is at what point in my analysis or doing data science work do I need to go to a mathematician and really pull them in and be like, hey, I need some higher level calculus or linear algebra or something to make certain I can find these other pieces, especially when we're talking about temporal differences in data, distance in data sets, and kind of all these other pieces to it as well, right? So those pieces. Math learning, right? Being able to pick up some of those new pieces that are coming out. Software engineering, right? So our mathematicians are really great at math, but not so great at engineering software solutions and doing those pieces and developing programs and everything else. And really a data scientist's job is not to produce a new tool every time a new problem comes out. It's really to use the tools we already have to kind of derive the intelligence we need from those data sets. If we went to them and said we needed a new tool every time we had a data question, right, we'd have how many more applications and tools on our desktop that an analyst has to use and try and figure out. One of the things that as data scientists and the data science community is looking at how we reduce the burden on downstream analysts that are going to be using our output or be using our algorithms and stuff so that they can more quickly add those into their tool sets without having to go and relearn a whole new tool base and a new language and all kinds of other things that we typically do, because that's a burden upon them, especially when we start looking at the increase of data flow coming at them, right, and an increase of events coming at them and trying to defend against pieces or even trying to attack against our adversaries or whatnot, right? We don't need them to have to add a new tool to their tool bag to use it downstream, right? Data engineering. So understanding how the data flow comes in, how we're going to store data, and all those pieces. And then visualization designer. Who's really crafty in the house? 1, 2 people, 3 people, right? Not a lot of people think about creativity in data analytics, but how do we make our pretty pictures of data, right? So one of the things is creative thinking. How do we actually move through the data? How do we then represent that data so that it really grabs the attention of somebody downstream or the consumer and says, oh, I really understand what you're saying here. Instead of just giving them a bar graph that's in multicolored rainbows with the median mode displayed on it and everything else, and they can see a peak. What is that really telling them, right? How do we get that information out? How do we display it? How do we make it available to consumers downstream? Any questions so far? Lunch kicking in for everybody? Nap time? All right. So do you even data science? Some of the things we thinking about now as data analytics within the cyber world and within the intelligence world and everything else is we typically go someplace, we gather the data up, right? So we're thinking about data generation. If you think about, a promiscuous internet connection or Ethernet connection, listening on the network, gathering information into Wireshark, right? Pulling all that data into it, right? Taking that data and moving it up someplace so we can aggregate the data together from different nodes and everything else, and then doing some basic data analysis. And that usually means, clicking on, say, follow TCP stream or putting it out and doing some sort of statistical information. And really what we're trying to get to is winner, chicken dinner, right? And yes, I worked a PUBG reference into my data science brief. Only a couple people get it. I'll have to work harder next time. Trying to get to the win, trying to get to the data, trying to have some sort of output so that, again, we can find the solution and find the information that we want to so we can influence operations and influence defensive means and influence decision makers in saving our resources and saving money in doing those things, and also getting us the capabilities to do things that we need to do in a much grander scale, instead of having to do over and over and over again. What it looks like even more so today is it's not just a single sensor, a single point of data acquisition. Those can be, fairly simple to take care of, but our analysts, our cybersecurity folks, and everything else are up against multiple streams of data coming in from different places, right, different tools, and feeding it into it. A lot of times what we think of, right, a lot of our analysts are looking at are going to places, and it's not disparaging any specific tool or anything else, but inputting data into Splunk, right, or into Cumulo or some other place, and then just displaying it back in like a SEAM is not really what we would call data science, right? It's just looking at events on the network, seeing some sort of graph output, and putting some of those pieces together. Now, do the tools actually allow us to apply some sort of machine learning and some sort of artificial intelligence to the back end of it? Yes. But for the most part, it's just looking at data as it's coming in and triaging it, right? Or you might be looking at some other places like Security Onion, where they're actually aggregating multiple different data types into a location and then displaying that back out. But it's still just looking at the data as it normally was, right? And not really correlating different events from different sensors and different places and pulling data from external sources in to enrich it, right? It's just looking at what the sensors are producing and displaying back to you in a standardized format. Right. We're getting a little closer on some of these things where we can actually look at aggregating data across from different sensors, and hopefully we push for standardization, like in the network defense area, right with STIX reporting or STIX2 reporting or different pieces like that. Those formats for those information, those reports are coming in, and we can aggregate those because we've got a standardized data set. And we can go back in, but it's still only looking at very specific angles, right? Very specific information. I mean, a lot of times, too, we were talking in between some of the classes and everything else with one of you. A lot of times where our network defenders are cyber folks, because we're so network-centric, right, and we have to be, we tend to lean on the top-level data portions of a session, right, or data within in the databases, to and from IPs, to and from ports, protocols, and maybe something else that an IDS or something has told us about the session, right? But we never really go and we look at things internal to the session, unless we're trying to deep dive into a little bit more. But a lot of times when we're looking at large volumes of data, right, the analyst is not going to go through and click through every single packet and look at every payload, right, to see if something odd is there that might have been missed by an IDS. That's where we need to be making it a little bit easier for them to find those pieces of not just the top-level data, but also what we would consider dark data. Has everybody heard of the dark data term before? Right? All that information that we gather and store, but only use 20% of the overall data that we have. The other 80% might be sitting out there and contain indicators or contain information that we just never get to because the SIEM doesn't know this there, or we haven't programmed the SIEM or something else to bubble that to the top and present it to us graphically, right? So getting to that information, dark data causes a huge problem on data storage and resource consumptions, right? It costs a lot of money to store lots and lots of data, and it costs lots of money if we're not using that data to its fullest potential. So being able to apply some of these things, the creative thinking process, to go out and look at something a little bit deeper than IPs and ports and protocols, right? And generating data and pointing other places, right? So one of the key tenets in data science, what we try to get to is we have these different data sources, we have different pieces of data and everything else that are inside of there, creating a new data model, right, that we can then go back into other data sets and see if it matches, right? And very high level here, right? That data model, right, might be pulling in two different types of metadata fields or data fields or something else to say, go into this other data source and see if you can find it. Or look temporally across data streaming in for the next 3 months, right? And we're going to apply this and see how many times we see something that's what we consider odd in our data, right? See if we can bubble that to the top and start taking a hard look at those pieces inside there. Our cyber adversaries are getting really crafty about doing pieces temporarily, right? Because they know that the streaming analytics and stuff that we have now just don't hold up to long-term scrutiny, right? So we have to be able to put some of these pieces in to get at those portions. My cool graphic here, right? So we're going to take our new data model and run it against other databases. And then we're going to have to output it and give it another visualization, right? Another bar chart. But the cycle needs to continuously be repeated, right? Just because we set in a new model and we've put it in there and we've output something and we can use it today doesn't mean that we don't need to stay on top of it. We don't need to be looking at the future pieces that we need to add into the model or adjusting the model if portions of our data has changed, or we have a different set of data that's coming in now, or if we've identified a different source of data that we can use another piece from. We can add that into the model and apply that to the data set and maybe go back and rerun through and see if we can actually refine it and output a better product to our consumers. Right? Influences on data science, right? So some of the driving factors that data science needs to be understanding. Right? So big data, big data, big data. Data, 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 big data. Everybody loves that term, right? You guys, I need some Red Bull for you, right? So big data, we've been hearing this for years, big data. In our world, right, we've heard the terminology BDPs. Anybody BDP? Right? So big data platforms. One of the problems with those BDPs, right, is a lot of those BDPs don't talk to each other, or they're not accessible through APIs, right, or not built in so that makes it more accessible to analysts. Even if we have an analyst that's sitting here who is super creative and has the fundamental skills to be able to go out and access some of these pieces, we've segregated that data off and we've blocked them from accessing it, except for accessing it through Splunk or something else that we've put in place and told them, oh, hey, you have to go here and do this. And then when they do go there, there's no way for them to get that data out and put it someplace else so then they can go to another interface and pull data. One of the things we need to do is make those accesses, those pieces available to all analysts, and build those in from the very start and make sure that they can access the data beyond just what the normal dashboard would tell them, right? Understanding what the big data problem is, and asking where that data is coming from. Another thing with big data is the human mind right now in our environment. We talk about things, and even on even on Google side and on the commercial side, they kind of understand, or there's some people that understand, but when we talk about events that we're looking for, right, or data generation and possibilities, everybody's got a Twitter account, right? Everybody loves Twitter, especially the person who's got their phone ringing. Just joking. So everybody loves Twitter. Some of the most prolific users, celebrities. Anybody know who's like one of the top people on Twitter right now being followed? Who? Kim Kardashian. She's one of the top ones. I think her and Miley Cyrus and a couple other ones, they have in excess of 100 million followers, right? And when we say we have 100 million followers and they tweet something, what does that do? What does that mean to most people in a data-wise, right? They think of it as a single event. Somebody tweeted something and it went out and people just read it, right? Well, really, if you look at on the network, on the interwebs, that's 100 million packets, right? And not just 100 million packets. If the person is logged into multiple devices and they're logged into Twitter, now that becomes a multiplication factor. If every person on the planet was following Kim Kardashian had 3 devices, that's 300 million sessions that we would get in, or 300 million packets of data we'd have to go through. No analyst is going to go through 300 million packets of data. And that's just from one person tweeting her followers. Add in all the other pieces and the understanding of all the other events that occur on the internet or on your network at any given time that's generating data that we need to go in and look for, right? Anybody know how many GET requests are issued from a single request for CNN.com? About 250 to 300 GET requests from actually the time you click it to the time it displays back on your page. That's one session in the human mind, but on the network, it's 300 events, 300 pieces of data that have now been generated from that singular event that we would think of, right? So all the DNS calls, everything else that's happening on a network, and everything else being aggregated someplace, and internal to those, aside from, again, the top-level information, to and from IPs, to and from ports, and everything else, right? There's all this underlying information and data that we can be using to refine and discover and hunt pieces, and also to protect ourselves, right? Or to be used in OCO operations and stuff, right? Segregated data repositories, we talked about that for just a minute ago, right? All these different data sources that we have that are potentially available, but we've segregated them off. And not just inside what our government repositories are, but external to us as well. Earlier, in my earlier brief, I mentioned something about opendata.gov. Has anybody ever seen opendata.gov? A couple people. Vast amounts of information, right? May not directly apply to cyber operations, but there's a whole world of data out there. Companies offer up data. There's large data sets available for free. Anybody hear of Common Crawl? A couple of folks maybe, right? Where they go out and they crawl the internet and bring back the web pages of every site that's not blocked, right? And aggregates all that data back in so you can go back in. That's freely available. You can download it and do data science stuff with it, right? We can use it in different places. So we need to be able to make those things available to our analysts that are doing data science work, because we can take information from one BDP, pull it out, and then enrich it from other information from across the world. Yes, sir.
So what about DHS's AIS, like automated indicator sharing standards like STIX and TAXI for sharing within our community? I mean, so they're sort of out there, right, from STIX 1 to STIX 2, and then cyber observables and even STIX query language. Where do you see the fit in that with putting together stovepipes?
So those fit in the same kind of stovepipes we were just talking about. Is while the formats are used for data exchanges, right, where are we putting that information at? And instead of you sending me, or one component sending me the STIX report, right, have it someplace where it's available to the workforce, it's managed in that one location, and everybody's feeding it, but having APIs and everything else so we can access that data, right, not just from Army's BDP and the Air Force's BDP and the Navy's BDP and DIS's BDP and DHS's BDP. I mean, everybody's own data storage, right, is causing a breakage in available information to be aggregated together so that we can make a better picture. Because if you think about how an adversary might attack something, right, if we're talking specifically about DCO operations, one sensor might see it, and they might be looking at something in our cyber, right, or some other training environment someplace, right. They might see an event there, and they might see another event over in the Navy side, and they might see an event over in DHS, right. Those three systems will never communicate to each other, right, that those events occurred unless you have some way of aggregating that data back someplace, right, and opening up those BDPs, right, to everybody that says, hey, you know what, I'm working this a threat intelligence. I need to go and look and query against all these places and bring back the information and have it in a centralized location to then get to those pieces. Also, taking that information and make sure it's through the classification levels, we have the information all the way through, and it's all common. And as much as possible, we can have as much work done at the lowest possible classification level, but also having it so that it's replicated up higher if we have to work in those environments to get to that information. Does that answer your question a little bit? Cool. Right. Increase the limitation of analytic tools, right? So one of the things when I went to GFHQ Doan's J2, and having worked in another agency for a number of years, went in and said, hey, we're going to do some data analytics. And I was like, hey, I need Jupyter notebooks. And they were like, not on my network. I'm like, but I need Python. I need to do some basic data analysis. I need my Jupyter. I need my, starting to get teary-eyed here, like my Whoopi is missing, right? And they weren't prepared for it because they had never had anybody ask for any type of development type tool. And what they were afraid of is that I was going to program something to be used on their network instead of looking at it as I'm using the scripting language to just process data. Can I do things? Yes. Can anybody in this room do a lot of things given access? Yes. But we need to be able to have those tools, and our support, our SSOs and stuff need to understand that environment they're working in, we're reaching limitations in the tools we're given. Splunk, again, not bashing them or anything else, really awesome tool. I love it. Same thing with Elk Stack. I love Kibana and Elasticsearch and anything else. But those tools are very limited in what we can actually do from within the tools. They're good for aggregating data and displaying the data back, but for true analytics, breaking down things and pulling data in from different places and manipulating and building those models out, it becomes a hindrance to that process. We're stuck in that stovepipe of only using that tool when we need analysts to be outside of it, doing things, applying data science type techniques to the data itself in a raw format and not being just presented back. Right? So understanding those, conveying that through leadership, right? So leadership, they hear, hey, I need some sort of development tool. They're going to be like, what do you need a development tool for on the network, right, on the class side? What are you going to do with Python, right? They need to understand those pieces so they can go and they can fight for those tools to be added to the inventory, and also to build in training so that the analysts know and the people who are going to be using it know the limitations and the things they should be limited to, right? And some of the concerns they have in and doing those pieces. I have a library I use for what's called Twilio. Anybody hear of Twilio? So you can use it for purchasing phone or like a virtual phone, right? And you can use it for texting. I have a Twilio API access in one of my Jupyter notebooks. When my algorithm is done or when my processing is done, it shoots me a text from my Python script, right? It pops it out, I get it on my phone. Hey, your stuff is done, or hey, your stuff has failed, right? So probably don't want to do that from a NipperNet machine, but we might want to at some point put something over in an enclave or someplace else that can do those types of things. Being careful of what we're importing in from the libraries, but making sure that we have access to external libraries and external tools that we can do rapid development with, right? Temporally along gaps and events. So this is like the bane of everybody in the room that's doing cyber protection type things, right? Cyber defense type things is the long wait between events. If I was really, really crafty and I really, really was going to be doing something that I did not want somebody to find me, I'm willing to wait a very long time between events. The problem with that is for the defenders. We're antsy. If we don't see something that's within the next few days or within the next few weeks, we move on from it. It's not enough to hold the attention of the analysts. So we need tools in place and algorithms in place and methodology and tradecraft in place to bridge that gap temporarily, right? Put something in place so that things bubble up for them and to start showing some of those pieces. I worked SIG development for a long time, and I always teased everybody that SIG devers are the hippies of the SIGINT world, right? Just because they spend a long time talking about a lot of things, about how they're going to pull pieces in and doing stuff to solve problems creatively, and the TOPI or the office who really wants something and wants it now, just like your manager wants it now, right? I want you to do this. We have to meet a deadline. I need this product delivered to me as fast as possible, and sometimes it's just not going to happen fast. Same thing with these events, temporal and long gaps in the activity, keeping everybody patient and everybody informed of what we do have in place, right? Via the algorithms and the machine learning and whatever it might be in place there, right? Limited data storage. Who loves data storage problems? Everybody loves data storage problems, right? In the IC, we like to throw a lot of money at data storage, right? And we're continuously adding more storage, and we're continuously adding more things to the storage, but are we really actually using all of it to its fullest potential? Well, that dark data that's sitting out there, again, we're looking at just maybe 20 to 25% of the data that's available to us, right? And there's a lot of other data that could influence these models and stuff that we're doing the data science with to aggregate pieces up to it and bubble up to the top. So we need to be able to do that. And also, it's not limitless, right? We've seen problems where we try to apply the same methodology of storage, or data storage that, say, Google does or AWS or Amazon does, right? The one thing is it costs a lot, and to them, to Google, it doesn't cost anything, right? To them, there's a nominal cost for storage, and it's a part of their doing business. They're willing to fill containers of servers and sink them into the ocean, right? And use ocean and everything else to cool it and everything else. And if something breaks in it, they just write it off, and they fill another container with servers and drop it in the ocean or build another building. They walk out and buy small towns in the Midwest and put server farms in them. They don't care. We don't have that luxury on the government side because it costs a freaking lot of money, and we just don't have time because we're working in an environment where we need it now, right? And they can build those pieces up. We need to be able to store that data, but we just don't have that capability. And then again, because we've segregated the storage off for the different services and different components and whatnot, those pieces, again, we're paying a lot of money and consuming a lot of resources. There's a lot of duplicative information that might be, if we aggregated it back together, we could say, hey, you know what, we don't need this piece anymore because we have some over here of it already, right? So those pieces can bubble to the top, and we can find that using our data science stuff to actually get into that and make it more useful and counter the limitations of that data storage, right? If I can shave parts of it off and I can store better data for longer, then that will help increase and limit the temporal gaps, right? So if I don't need to store a whole bunch of the black data or dark data, I can keep more data longer, right? And that will hopefully negate me missing something that might happen 6 months from now because I wasn't able to store what happened today because of that storage limitation, right? Again, we've heard it, I've said it about 50 times already, dark data. It's the bane of any data person's existence, whether you're in management or you're a data storage person. It's really cool if you're a data analyst and you can actually get to all the data and see it all. It's a wealth of information that's available to us to do different, say, cool things with, right? There might be something underlying there that you can underpin something else with to use within your models to find those threats and to use it against to propel, do OPE with it or whatever it might be, whatever your job focus is and what you're applying your data science techniques to, right? Using it to its fullest advantage and opening up your mind. It's almost like, you have to sit and meditate for a little bit and let the data universe open up, and then you can kind of see everything that's before you. Told you I was kind of a hippie. Right? The good, the packet, and the statistics. This is what we normally think about, right? When we're talking about a network defender or somebody else, we're getting packets. We can see packets going up and the increase of data and everything else on the daily basis, right? But it really goes beyond that. Again, going beyond packets and getting down to what's actually going on inside the payloads and going on what's surrounding those pieces. We talked and mentioned Twitter. When an event occurs, what happens on the network surrounding those pieces? What does the adversary do to our networks? Is he looking at other things? What do they do to our networks when they're not throwing an attack at us? Those different pieces that are inside there, right, may not bubble up to the top just because there's a spike in traffic and we see a spike in a graph someplace and be like, oh, this can equate to a user activity. Maybe we had a surge in operations or something. We see a spike there. Okay, we can write those pieces off. Plus, it lulls us into a false sense of what's really going on. If I see no activity, does that really mean that I'm not being exploited? No, right? So being able to use some of those pieces to bubble those again to the top. And to go beyond traditional cyber indicators. Again, we're looking for IDSs or host-based systems to say, hey, there's a rule that fired off. The bane of any network defender's life is probably most attributable to antivirus, right? Because there's so many different vendors and doing so many different things and not sharing those rules amongst each other. So depending on what I have on my systems, right, hopefully not Kaspersky, it can cause different things and lulls into different perspectives on what's actually happening on our networks and everything, right? So data science and the cyber operations from the OCO standpoint, right? Understanding adversarial digital world. right? Being able to go out and pull data from open source areas and see and merge that with information that we have from reconnaissance or anything else we might need to really paint an entire picture. Earlier in my ICS and IoT discussion, we talked about all those IoT devices and everything, and the ICS devices. Those all become potential vectors for events that I can use for myself to provide situational awareness for my troops or anything else that might be going on, right? How does a data scientist going to go and pull all that information, right? A data analyst going to go and pull all that information and rapidly assess it and make a determination on what needs to happen going forward, right? To provide that warfighter in the field, right? The direction and the top cover, right? Before they go into someplace. Looking at that vast amount of data, right, takes I don't want to say a huge jump in skill level, but there's a lot of things they have to understand and need to be able to apply some sort of data science techniques to the data to aggregate it back down. Again, they're not going to look through 300 million tweets, right, to kind of build a picture on who's following, Ariana Grande, right? They're going to need some help in doing that piece, right? Providing opportunities. Again, providing those opportunities that we traditionally would not think of. Again, in the brief earlier, we were looking at gas stations, and on the gas station, they put these Lantronic devices in, and those Lantronic devices have full-blown web servers and mail servers on that are potentially not password protected. So it gives the opportunity. How are we going to go through all of everything that's been called in Shodan, right? Pull the information out of Shodan, and then go through and find those different pieces and aggregate that to other data to find opportunities, right, that are available, and enrich pieces that are coming in from different data sources that we have publicly and also things that we hold privately inside there, right? For defensive cyber operations, it helps us go beyond the traditional dashboards, right? Applying these higher level mathematical equations, we can then output that information in a dashboard, right? But we have a little bit more confidence in going from just, hey, a packet pinged an IDS alert and I can see the CVE for it. Now we can actually say, hey, something else that would not have met the thresholds for my traditional indicators or traditional activity has caused a spike in activity, right? Looking at data traversing a network or something else in conjunction with other pieces. And also breaking those out so that those pieces can be, or those algorithms and data science methodologies can be applied on all the BDPs and all the data repositories to find the components within there that might be associated with my activity on my network, right? Again, it's not red light, green light. A lot of times we just look at that and make sure the circuit's up, down. I don't have a potentially lot of data flow going across it, so I'm nice and even, right? And it also can help go hunting, right? So one of the biggest things in the DCO is if nothing's happening on my network, am I actually not being attacked? Probably not, right? They're probably still coming after you. They're probably doing some things. So how do we switch from just looking at red light, green lights to actually going into the data and finding something? Sitting around, how many of you have ever worked like a mid-watch before? Like overnight, right? Most boring amount of time on the planet. You sit there and you stare into the ceiling and waiting for something to happen. You could be sitting there and be like, hey, you know what? I wonder if I could find this in the data. You could just go in there and write something and pull some data down and munch around. Those things, those areas, then allow us to go and train and find those pieces. And if we train our analysts and our network defenders and our OCO operators or anything else to do some of those pieces in that downtime in between operations, we might find that we can bubble those pieces up a little bit more. We can also help it with crowdsourcing it as well, right? So taking these pieces, storing it off in locations. I love Jupyter Notebooks. There's something on the low side now, on the unclass side, called Notebook Gallery. Anybody ever heard of Notebook Galleries? It's a place to store the notebook gallery. You can store notebooks. You can share notebooks. So the crowd, the community can see what your notebooks look like, can provide assistance, can download those notebooks and use them in their own analysis and their own tradecraft and everything else. So being able to put those pieces out and crowdsource that information in those tradecrafts, very important, especially when we're sharing data science. We don't have a whole lot of data science in our community right now, again, because they're being siphoned off by commercial sector, and they get in and they find out that it's not really that exciting a job, so they want to be an analyst and not a data scientist. Can't blame them, right? Two major things within data science and cyber operations we hear a lot of, right? So machine learning and artificial intelligence. Machine learning, right, for the basis of this talk, right, is something we teach the system of the programs or the algorithms or everything else to do that it will repetitively have to do, right? So if it's checking for like sentiment analysis, or we have sentiment analysis going on inside of it, so we can find some sort of topic modeling, right? We need that machine to eventually, or that algorithm to eventually identify if somebody misspells a word, right? Can it learn that the bomb, right, means that you're really cool, right? Or that it's really bad because it's not the bomb, right? So being able to make that determination and teach itself what it's doing, right? And not to make determinative actions, right? So machine learning should not be or would not be applied to, I need to make machine learning available to make some sort of active response for me, right? That's not what it's really going to be for. Artificial intelligence will be that piece, right? Machine learning, again, works really well for like sentiment analysis, topic modeling. Those different types of pieces are going in there. Artificial intelligence, right? That's teaching the machines to make some sort of intelligence decision, right, when it finds something, right, in this model to then react and do something, right? To be able to make the determination, is this the threshold at which Steve wants me to shoot back at the enemy, or should I drop packets, or should I do something else, or should I drive the car into the left lane vice the far right lane, and I want to be in the far left lane going as slow as possible like the rest of the world? Not really. But those types of determinations, right, that we need them to make in there. One of the cool things, anybody seen Google's Google Assistant booking appointments? Works really well for haircuts, right? Not so well when you're ordering Chinese food so far, right? Those types of things, the computer's interacting with other humans to make those determinations and make decisions that we've kind of told, yeah, go ahead and make me an appointment for this day, and if not, then you have these other 3 days because I've given you access to my calendar. You can see where I have something on there, right? But that, again, that falls back on us as humans, right, to teach that machine what we expect of it and to give it access and to make things certain. If I'm going to use Google Assistant to book my appointments, what do I have to do? I have to put all my appointments on there that it doesn't know about, that it hasn't made for me. Because if not, then it's going to just make a determination that, oh, Steve has a gap in his schedule. He puts in a new one, and then I have a conflict now that I have to resolve between my super awesome barber and my wife who wants me to be at a recital or something, right? Which never goes down in my favor. But those are the types of things that we needed to make, right? Some of the things, though, with these pieces, again, machine learning, right? It can pick up those things, those repetitive tasks, and all those other pieces. With artificial intelligence, we have to be really leery and listen to artificial intelligence discussions all the time. And one of the things that scares you the most is at what point does the machine learn to cheat? Right? It starts learning how to do something, and it might make the determination, well, the best way to do something is to just keep a copy of something else, and then whenever Steve asks for it, give him the copy that I've kept from 3 years ago, right? And doing it over and over again. So we have to be careful of the machine becoming aware that it can cheat. And we've seen some of that in some experiments and some testing of it where they look at overhead photography and it says, hey, here's a picture of these buildings I want you to take, and I want you to output that later on in the exact same way without having the building. And it does. It cheats. It just gives you back to the original picture that it gave you, right? Instead of giving you a new picture. So those are some of the things we have to be kind of cognizant of as we move forward and everything else. Again, machine learning, artificial intelligence, though, is not going to replace what? Humans actually going in and looking at the data, right? They'll be able to do explicitly what we tell it to do and say, hey, we want you to look at sentiment, but it's never going to be like, hey, I was looking at also the sentiment stuff, but I also saw that you wanted to do some sort of recipe or something else over here, so I did that for you. And like, no, that's not what I wanted you to do, right? So deviation from what it's trying to do or what you've told it to do is not going to happen. And we don't want artificial intelligence doing that either, right? Another way. The way of the data science warrior or cyber warrior, right? Skills to be honed. So algorithmic thinking. Who thinks in algorithms on a daily basis? couple. We might not realize it, but we do communicate in algorithms, right? When we pass each other recipes, or we tell each other directions, or we tell what's going on our daily basis or daily lives, right? Some of those pieces that we're communicating, we're communicating in an algorithm. If you're going 55 miles an hour and it's 100 miles to the location and you hit the brakes so many times, you're going to get there at this time. That's an algorithm, right? That's math that we define. We can have an outcome. We can tell you when you're going to arrive there, right? Those different types of pieces. And recipes. We teach a class on data science, and one of the things that we do in it is we have the students share recipes with each other, right, to see how we communicate and how we communicate those pieces to each other so that we can understand. We need to use precise language when we're talking to a data scientist. We're coming up with a data science solution to something, right? We can't say season the shepherd's pie to taste with salt, right? A computer would not know what to taste is, and everybody in this room is going to have a different taste. So we need to predefine and use precise languages within those pieces, within those algorithms, and within the data science models to put those pieces out. Creativity. I harp on this one the most because in data analytics and in data science, we have to be creative about how we're going to do things, right? How we're going to find a solution, how we're going to output the information to our consumers, and how we're going to save ourselves from having to continuously go back and repeat over and over and over again the things that our customers have asked for, our consumers have asked for. I ask a lot of times when I'm interviewing for people coming onto the company, the first question I ask is, what do you love to do creatively, right? And if they say, well, I had one guy one time tell me he liked programming video games, and I asked him how he was going. He's like, I got too hard, so I stopped. And I was like, great, this job's not for you, right? Because we need people as data analysts, as data scientists, right? We need people to be able to go in and not get frustrated, because there's been plenty of times when the data hasn't aggregated properly, or my algorithm stops working because the data provider decided to start putting nans in or nulls into the table instead of what I really wanted was an integer or something else, right? Everybody see the guy in California, the security researcher? Recently they got $12,000 worth of tickets because he made his license plate null. That's a great data science problem, right? He thought he could beat it because he knew the data, and the data was like, no, I'm going to show you a little trick I have because I'm going to know your address, and now you're null to me, right, and send it all to you. So he didn't fully think out that piece, right? We had that same problem when we're doing data analytics. I don't fully understand all the data that I'm getting, or my data source changes it on me at the last minute and stuff, or I may not have connectivity to another piece, right? Multidiscipline. And what I mean by this is a lot of time we stovepipe folks into different specialities, right? You're an Intel analyst, or you're a network defender, or you're an OCO operator, or whatever it might be, right? And put them in front of a position and teach them how to do that piece. The data scientists and advanced data analytics folks we need doing this stuff have to be a little bit of all those. They have to understand the full breadth of the CNO world, of a CEMA world, and everything else, so they can understand, okay, when a warfighter says they need X, well, what's some of the data I can go into? What's some of the pieces I can aggregate? Where is the data stored at? How do I normalize the data? How do I write a script to do these pieces? So they're going to have to understand all those different pieces, right? And that's a lot to ask of a single individual, but that's what we have to do, right? And it's to kind of drive the next one, which is non-traditional analysis, right? Looking at a SIEM all day long and reporting that on a PowerPoint that, hey, we blocked X number of sites from scanning us. Great, awesome, right? I blocked so many emails that contain this bad word in it, or whatever it might be, right? That's great and everything else. But we need analysts, true data science and data analytic analysts, to look at non-traditional ways to use the data and everything else, right? To aggregate things you normally wouldn't think about aggregating, right? One of the other things, too, we need probably a little bit more of, and I've talked to the owner of my company about this, too, and she kind of agrees, right, is it's hard for the military commands and even other places to really take junior analysts and stuff and develop them out over the years. Maybe we need something like a private sector apprenticeship program where they come out and they work with a company for 6 months, right, to see what we do with data and what we can apply and do those other pieces, or even through mentoring programs where maybe they don't spend 6 months with this, but they pair them with a peer or a more senior peer in the data science world to say, hey, I have this question, how do I do X, right, to help lead them through the way. Well, a lot of junior folks, and even in my company, I have some senior guys who are trying to pick up data science skills, and they just don't understand pieces, and they'll come to me like, hey, what does this mean? And you can kind of show them and string them through the process and teach them those pieces as we go along. All right. That. Yep.
For that last one. So back to it, the last one, I think, because I know this is new, but it's cryptographic or cryptography, the info security of data. That's the last point in this, I think. I'm only pointing that out because again, data's been around a long time, but if that data is corrupted via by a network device that doesn't want to work anymore, or by an adversary, then all of your models can be thrown way out.
Way out. Yep.
So I'm only pointing that up there because cryptography and understanding cryptographic or blockchain in data is really important for data science.
Oh yeah. We didn't go too deep in like the data storage piece, but that is, and understanding the ethics behind it and some of the other pieces we're doing with data, plays a very big role in this. But I was talking again, like in between the class and everything. Has everybody seen the movie The Great Hack? Everybody seen that recently? Cambridge Analytica, their data and everything else, so the ethics behind aggregating data. We were asked to do one project, and we just went back and said no, because the aggregation of that data, although it's all unclassified, the aggregation of it, once we put it someplace, becomes really, really sensitive, and we don't want any part to do with that, right? And trying to inform the customers, right? If you do that, it's going to be bad, right? Understanding, paying attention to your data, right, in case it does get disturbed or broken or disrupted in some way, right? How to circumvent that or how to recover from it and how to rebuild, and maybe building in some AI to then monitor your other stuff. And there's a whole deep world of those pieces and everything else. Thank you. Vast sets of open tools that are available for us, right? So Jupyter Notebooks. Everybody loves Jupyter Notebooks. Everybody raise your hand. Whoop, whoop. Somebody out there has to like Jupyter Notebooks besides me. All right. Python for data analytics. See this one, too. So I have a book in my backpack, Python for Data Analytics. I carry it with me wherever I go. Right? There's just so many different things within Python, the scripting language, and everything else to do that's just incredible. Just nice to have it there. R for statistics, right? D3JS. So anytime you've looked at visualization or anything else, it's probably been because of D3JS or some other JavaScripting or something else. And you're looking at Tableau or some other Power BI tool or something else to render it back out. Spark, Scala, PySpark, those things that kind of do long-term map reduction, deep learning type of languages to build out large data set analytics, right? I have to make these tools more available across all the platforms as well. I mentioned a little bit earlier, right? Went into the DISA and said, hey, I need Python on this workstation. I need Jupyter Anaconda so I can do some analytics and everything else. That's great. If they came back and said yes, it would have been really awesome. They said no, but we also need those tools across the entire environment, right? So I can do some sort of analytic on a higher side or higher classification network, and then take and sanitize it on its way down so I can work against unclassed data, right? And vice versa. If I do something on that unclassed side, I need to be able to pull that analytic or that technique up to the high side so I can apply that to the data up there as well, and maybe even expand as I go through. So I'd be kicked out. So that's been our hour. There's many more discussion points we could talk about in the data science and the cyber world, right? It's an ever-changing environment, and definitely data is not ever going to go away. So if you guys have any questions, I'll wait around up here. I hope everybody got a little bit something out of it. I appreciate it, and good to go. Thank you. Oh, thank you. Appreciate it. Thank you.
So you now have contention in the private sector, petitions being signed, not to work for the government.
Oh yeah. It's that I think think with like the exposure to Cambridge Analytica stuff, and I mean, in our community, we've been doing the same thing. It's just like once it got exposed to everybody outside of here, they kind of like freaked out.
Yeah.
And my wife, the night she watched that movie, we had a 2-hour discussion over ethics and law, right, and what it meant and all these things. And I taught a class 10 years ago talking about Google's, not intrusion, but use of data that we give it and stuff. And it's been around. I think it'll wane. People will go back to being just, I got something free. I get a free app, click on it, and
Because you look at before that, I think the program was made, right? Artificial intelligence. Google was and then they said no. The employees said no.
yeah,
We're not going to support you.
there's a whole bunch of other employees that'll be like, yeah, I'll do that because that's cool. There'll be different aspects of it. Hi. Yes.
I mentioned about doing the recipes. Back in 6th grade, I had this teacher whose name was Mrs. Robbins.
Yeah.
She had us do this one exercise that I had never relegated as being an algorithm, but kind of went
Yeah.
along with that, where we had to write a step-by-step instruction on how to do something we were familiar with.
Mm-hmm.
And step 1 is this, step 2 is this, step 3 is this. And we have to get extremely precise. First you put on, like a recipe, first you put on the hot pad or use a hot pad before you
Right.
open the oven to pull out the thing before you burn it.
Yep.
And she wanted us to get that precise.
Yep.
And the one that I had to do was make fudge or something like that. I had never seen a candy thermometer before in my life.
Yeah.
I had no idea what it was
Yeah.
or how to use it. And the instruction that I was given was to put the candy thermometer on the pan. Like, okay, so I just put it in, it's all cockeyed, and the girl who was reading it, her instruction was, she's like, no, I said put it on the pan.
Yeah.
I'm like, okay, so I pick it up and I place it across the top.
Yeah.
She got mad at me, took it, and then clipped it. I'm like, oh, you meant clip it on.
Flip it on. You got to use that precise language.
Yeah.
The same thing with the scripts and everything else, and understanding all those pieces and going through the iterations and all that good stuff.
So for the mentorship piece, what do you think of Kaggle?
It can be used. We have Big Blue Button and some other, online vectors to get the data out to them, or sessions, Skype. I mean, I'd be willing. I mean, the colleges stuff pair people up with like industry people that kids are going to be graduating into, to kind of mentor them along. Kind of the same way, like have a cadre or open source group of folks be like, hey, I put my name in the hat to be a mentor, and then anybody can go in and be like, hey, I want Steve to be my data science mentor or my data analyst mentor.
I like Kaggle just because you can see how everybody else is doing it, different ways of getting to the same solution.
Yep.
Different ways, how slight differences make a big difference in the outcome. You can learn a whole lot just by reading the forums and reading people.
Stack Overflow is my daily read. Go on to Stack Overflow. Thank you, appreciate it.
So we have a small niche need for data scientists. Do you have any companies out there that do a good job finding guys like that in cleared space especially? Because that's been our biggest, hurdles to try to find people that meet kind of the requirements you put out.
There's some. Here, let me get out of this really quick. No, man, you're good. Close this. There we go. I can't think of any right off the top of my head. You call me Maryland, so
That's what
oh, we're right on. We're right on the corner.
Yeah. So, I'll send you a note.
Yeah, I have some people that I
Okay.
know.
Yeah, and sometimes it's just what their resumes make. So, all right, brother. Thanks, man. Appreciate it.
because I liked your topic. So I'm hoping that wasn't wrong in where I placed it.
I think we'll be okay.
Okay. It's been interesting. It's off and on for people coming in.
Oh, yeah?
Yeah, sometimes we had 90 for the first two classes this morning and 39 after lunch and then 63 in this last class. So it's hard to say. Thanks, Steve.